In this video, we're going to take a look at quadratic transformations. So with quadratic transformations, we compare different quadratic functions to what we call the parent function. So our parent function of a quadratic is f of x equals x squared, where we have an axis of symmetry at 0 and a vertex is right at the origin. So think about this is our basic quadratic that sits right at the middle of our graph with a vertex at the origin and the axis of symmetry on the y-axis at x equals 0. So we compare every other quadratic function to this parent function, and we discuss whether or not it shifts left or right, up or down, if it's wider, if it's more narrow, if it opens up, if it opens down, all of that good stuff. So that's what this lesson is talking about. So quadratic transformations are, like I say, taking that parent function and comparing others to that one. And so we use vertex form to do this. So we've talked a lot lately about vertex form. And in vertex form, we have an A value, we have an H, and we have a K. So those are the things we look at when we look at quadratic transformations and how they change the graph. So H changes the graph. That's our X of our vertex, notice. If it shifts left, it's a positive value in that parentheses, and you go left that many units. And it goes right if it's a negative H, and you go that many units. And we'll look at some examples of what that looks like in a minute. For K, notice that's the Y value of your vertex. So that makes our graph shift up if K is positive, and down if K is negative. Then A actually does two different things. If A is negative, it makes our parabola open down. And if it's positive, it makes it open up. And if A is between 0 and 1, a good example would be like 1/2. Our parabola is more narrow than the parent function. And then if our parabola has an A value that's greater than 1, like 3, our parabola would be wide or look kind of flat like that. And the narrow, of course, looks really skinny. Okay, so let's take a look at some examples. They don't take very much work. They just take picking out what's happening. So how is the quadratic function, this is our parent function, we always compare to that, transform to become g of x equals x minus 3 squared. So this is our h, and we think of a negative h, so this is like a minus 3 right here. That's going to shift this to the right 3 units. And then that's all that happened, because the 3 is the only thing different between f of x and g of x. On number 2, it says, how is the quadratic function f of x equals x squared, so our parent function, and this is supposed to be a 2 right here, transform to become g of x. So notice we have two things happening. We have a negative out front. That makes it open down. So we'll put opens down, and then the positive 2 is our h. So a positive inside of that parentheses makes it shift to the left that many units. So we'll say left 2. Now let's look at example 3. It's supposed to be a 3. So they're always comparing it to the parent function. How is the quadratic function transformed to become x squared minus 5? So if all that happened is minus 5, that is our k. So notice it's back here in the back where we would pick out the k or the y value of our vertex. That makes it shift up or down. So if it's negative like this one, it would go down 5. And then that's all that happened between the parent function and the new function. All right, let's look at another one. How is the quadratic function, again, this is our parent function, compared to our new function? So in this one, we have several things going on. So we have a is 1/2. If a is between 0 and 1, it makes it have a graph that is narrow. So let's put narrow, because a was equal to 1/2. And then the minus 1 inside of that parentheses makes it go to the right. It's kind of the opposite of what you would think would happen. If it's minus, it goes to the right that many, and if it's positive, it goes to the left that many. And then the 3 that's out back here is our k, or it's like the y of our vertex. So that number makes it go up or down. And a positive 3 would make our graph shift up 3 units. So this one had 3 things that happened to that basic parent function we started with. And that was example 4. I don't know why these numbers aren't showing up. The next one is 5. Let's take a look. How is the quadratic function transformed to become g of x, which is negative x squared plus 9? So the negative in the front is our a, and it makes it open down when it's a negative. And then the plus 9 is our y value of our vertex, or it's like the k we call it. And that does what it looks like, but it's up or down. So like up is positive. So this one goes up 9 units. And then our last example, again, I don't know why the numbers didn't show up right, but this is number 6. How is the quadratic function f of x equals x squared, so our basic parent function, transformed to become g of x equals 2x squared plus 7? So a is equal to 2, which makes our graph wide, because a was equal to 2. And then the positive 7 makes our graph shift up 7. All right, so something I've done for students in the past is I've written out the vertex form. This might help to make a little more sense of everything. Let me make it a little thicker pen. Y equals, and then I'm going to use the different colors I've been using. So we have A, and then we have X. Then I've been using green for the H. So I'm going to put plus or minus H squared. And then I've been using red for the K. So let's go through each one of these. So if A is positive, it opens up, and negative, oops, let me write this a little better. Negative, it opens down. Also looking at A, if A is between 0 and 1, it makes it narrow. And if it's greater than 1, it makes it wide. So all of that deals with the A. The H goes right or left. So if it's positive H, it goes to the left H, like however many that is. And if it's a minus H, it goes to the right H units. So like if that's a 3, it goes that many units. All right, and then the K is up or down. So positive K makes it go up, and a negative K makes it shift down. So that